Hello.
Hey,
Hello.
How are you guys today?
doing good.
I'm a bit tired, but
That's
I've been walking all day, so
ah.
like on school walk, so I'm quite, I can't wait until it's nighttime.
It's time to go to bed.
Yeah.
I hear you. Okay. Hmm. Hi James, how are you today?
I'm fantastic. Tired from work.
Where do you work?
I work at Menards.
Ah, Menards. Hey Cody, how are you?
I'm good. Just took a nap.
Great, then you won't fall asleep during my class. Or maybe you
I
will.
hope not. I have some coffee.
And another James just popped in. Hi James, how are you?
I have a question. Where can I find the recording to the first class we did?
Hang on. What do I do here? Share my screen and where do I want to share my screen? Hang on a second. Can you see this, which shows my Ivy Tech
Yeah.
page? Okay. I couldn't figure out how to put him in here, so I have uploaded them to my YouTube channel. So if you click on April's YouTube channel, I was able to figure out that link. It'll say open in a new tab. Is that showing up for you?
Yeah.
Okay, now, unfortunately, I'm not the most, there may be a better way to do this, but I had it open at least to my playlists, and I've got all sorts of playlists in here. But I at least at the beginning of each playlist put what college it was. So right now I only have one for Ivy Tech, and it's right here. I don't know how you can order these things or not. I haven't figured that out. But if you click on Ivy Tech Math 136 Zoom playlists, I've only got the first one, which I'm going to stop that, which is what we did last Wednesday. Will that work for you?
Yeah, that's perfect.
Awesome. Cool. Okay. And I hear people pinging in and out and pinging in and out. Let's see. Let me stop that so I can see who else here. Ah, ding dong. And I've just got it set so that when you guys join the class, it has you muted. And it doesn't have your video on either. You don't need to keep your video on. Just need to see my lovely face. And of course, I'm just going to share my screen like I did the other day. Not sure how many more people I got coming in, but it's 4:01, so I'm going to go ahead and start. Share my screen again. I'm going to go back to, here it is. This is my home page. I was able to figure that out. And at the bottom, I added 2 videos. If you click here, you can watch a quick hello video from me. And then I put in how to navigate through my math lab. It's under 10 minutes. Just showing you the ins and outs of my math lab if you've never used it before. So that's in there for you. And then modules, which is right here, I added that. And you can only see module number 1. The rest of this isn't shared yet. But so you'll see this. I'm assuming it looks just like this. And I've got the first PowerPoint we did the other day. And then I also, when I was done writing all over the PowerPoint, I saved that also so that if at a minimum, if you didn't want to go watch the whole video, you could at least see, you know, all my lovely drawings. Oh, look at the pretty colors. So that's in there for you also. Of course, I scribbled on some of it, so it might not make much sense. Oh, and crap, the highlighter. What the heck? The highlighter covered it up. Where all that yellow is, that's where the highlighter is. So you may have to watch some of the video because the highlighter, you know, jacked it up. Like that one there too. Aw. Well, that's weird. It didn't look like that, did it, when I was teaching it? Guess I can go watch my video. So anyway, that's under modules. So, and then today's PowerPoint is here, and I'll have the next PowerPoint up for our next class. I should have 1.4 and 1.5 done by Wednesday. I don't know if I'll get through 1.4 and 1.5, but I'll get through 1.4, and I'm hoping to start on 1.5, at least get started on it to help get us caught up. So, and did this work for you all, the Zoom link? You can see all these and
Yes, it did work.
awesome. So I figured that out too.
Did work.
And cool. All right. So back to my homepage, I guess. Oh, no, back to my PowerPoint. So can you see the PowerPoint?
Yeah.
Okay. Because the other day it wasn't letting me jump back and forth for some reason. So, all right. And how do I make this go away? All right. Cool. Does anybody have any questions about anything before I start on section 1.3?
Am I going to need a calculator today?
Nah, I don't think so. You'll need the calculator when you take your first test.
Okay, I still haven't bought one yet, so that's why.
Okay. All right.
Are you in the tutoring,
No,
in the Vooch? Okay.
nope, I'm not. Nope. But if you need help from me, we can always set up a separate Zoom meeting. I'm open to do that. If you're not getting any help in the math lab and you want my help, just send me an email and we can arrange a time and we can Zoom together and I can share my screen that way and help you that way.
Okay.
All right.
Is there a calculator that you recommend?
You actually have to have, there's a required calculator. How do I get my picture back on here? Can you still see me?
Yes, I can still see you.
Okay, because I couldn't figure out, oh, there it is. All right. I just want to make sure it's in the picture. It's this calculator. It's in the syllabus. And it's also in that little video that I made on the homepage where it's Meet Your Instructor, because I introduce myself and talk about myself a little bit, but then I also talk about the requirements that you're supposed to have. So this is Ivy Text Calculator. There's actually 2 versions of this. This one's the older version, and then there's a newer one where the button is a lovely lime green color, and it's a little thinner than this one. So I don't even know if you can find this one in the stores anymore, but they're the TI-30XA, so it's Texas Instruments. All right, so let me shrink that out of the way. There we go. All right, so I'm ready to start section 3, woohoo. And this covers complex numbers. And we're going to be dealing with the quadratic equations again, except this time your answers will come out as complex numbers. So there's your objective for the day. Okay. In the past, when you were asked to calculate like the square root of -4, and you'd put it in your calculator would give you an error message. And then you would always, you know, say, oh, this is undefined because you couldn't find an answer to it. Well, that's because you hadn't learned about the imaginary number. And the imaginary number is I, which is right here. And it actually represents the square root of -1. Now, the definition says the imaginary unit, which is denoted by the letter I, is the number whose square is -1. If I were to square the square root, wouldn't, like we did the other day, squaring square roots cancels them out. So all you would be left with is the -1. So when you take I and square it, you actually make it into a real number, which is -1. But I by itself is the imaginary number. And again, I gotta make myself go live here. I don't know if you can see my shirt, but I'm wearing one of my math shirts today. And it does say the square root of -1, and then 2 cubed. And then there's that Greek letter sigma and the Greek letter pi. But the square root of -1 is I. And then 2 to the 3rd power means 2 times 2 times 2, which is 8. And then sigma in math class means to do a summation, which means sum things up, add them up, you know, a sum. And then pi as well, everybody knows pi. So this basically says, I ate some pie, and it was delicious. So mathgeek.com if you're looking for this shirt. All right. Thanks for the giggle. All right, so there's where we're at. We're now going to deal with imaginary numbers, all right? Okay, so, and this is basically what I just said. Before you learned about imaginary numbers, if somebody gave you the square root of -25, you'd say that's undefined. But now that you know about imaginary numbers, it's like you literally break this down to be the square root of 25 times the square root of -1. Because 25 times -1 is -25. And then the square root of 25 is the 5. And the square root of -1 is the I. So your answer is 5I. I know it's out there. But that's the answer. So, oh, and if I went back to, where was it? This one. When I said the square root of -4, first I said it was undefined, but now I would say the answer is 2I. Because the square root of 4 is 2, but the negative sign, it's like you're breaking it up. You're saying the square root of 4 times the square root of a -1. The square root of 4 is the 2, but the square root of -1 is represented by the letter I. Kind of like in Sesame Street, you know, today's class is brought to you by the number 2 and the letter I. Yeah, good times. Okay, so let me go here. Okay, complex numbers. Complex numbers are in the form of A plus BI, where the letter A and the letter B, there's going to be some numbers there, some real numbers. They could be fractions, they could be whole numbers, they could be decimals. The real number A is called the real part of the complex number A plus BI. And then the imaginary part is the I. So it's part real and it's part imaginary, which makes it complex. Get it? It's very complex because it's part real and it's part imaginary. Imaginary numbers are used in a lot of real life applications, such as electronics. I don't know if Keith No still works at Ivy Tech, but when I worked there years ago, he would come to me and be like, April, would you please make sure that everybody understands imaginary numbers because they need them in electronics? And I'd be like, okay, I got you. I got your back. You're also going to run into them in quadratic equations when if you remember the, oh my God, the square root part, you know, the square root of b squared minus 4ac, sometimes that comes out to be the square root of a negative. And in the last section, if you ran into that, you just kind of had to stop and you'd click on at the bottom where it said no solution. But now that we're covering imaginary numbers, you can't say that anymore. So you're going to have to keep going and get I involved. And so anyway, all right. So what are we going to do with these suckers? We are going to add, subtract, multiply, and divide complex numbers. And that part actually isn't complex at all. Well, adding and subtracting is not complex at all. It's very easy. Multiplying and dividing I'd say is a little bit more complex, but here's the basic rule for adding and subtracting, although they said sum and difference, but that's the same thing. Literally all you're going to do is if you take A plus BI, which is a complex number, right? I got one complex number here, and I want to add it to another complex number, C plus DI. Now keep in mind when you're doing your homework, where the letters A, B, C, and D are located, there'll be numbers there. They could be positives, they could be negatives, but there'll be numbers there. You are simply going to add the real part to the real part. You're going to add the A to the C. That's what they're showing here. And then you're going to add the imaginary part to the imaginary part, these two. And that's what they're saying here. And that's it. And the same thing works for subtraction. If there's a subtraction sign in between, you're going to take the A minus the C, A minus C. And then you'll take the BI minus the DI. That's what they're putting here. So let me show you one of those. They wrote it all out already in their PowerPoint. So let's see. I've got a 3 plus 5i. That's the first complex number. And I want to add it to this guy, negative 2 plus 3i. So I am just going to take the 3 and add it to the negative 2. You just add the real part to the real part, which is what they wrote right here, 3 plus negative 2. I would never write that down. I just try to look at it and do it in my head. And then 3 plus negative 2 adds up to be a 1. Then you go back and you grab the positive 5i and add it to the positive 3i. And they wrote here 5 plus 3 and just let the I hang out there. But it's just like combining like terms. If it was 5x plus 3x, I'd have 8x. Well, I got 5i plus 3i, so I got 8i. And that's my answer, 1 plus an 8i. So if you take a complex number and add it to another complex number, guess what? You get a complex number. It's very complex. And then the second one, hang on, I'm going to rewrite this one because I've got 6 plus 4i minus 3 plus 6i. Now, if you struggle with subtraction of signed numbers, a lot of times I won't do it the way they're doing it. I'll actually look at it like I got parentheses and I'm like, I want to get rid of the parentheses. So I would be like, hey, well, technically there's like a 1 right here. And if you distribute 1 to this, you just get the same thing. Whereas back here, it's a minus invisible 1. And if I distribute that, minus 1 times 3 is minus 3. And minus 1 times 6i would be minus 6i. And then all I would do is combine like terms. Let's see, some more colors here. I would say, okay, I've got this 6 right here. And down here, I have this minus 3. If I combine 6 and a negative 3, that would be a positive 3. And then if I take my positive 4i and come down here and he hooks up with the negative 6i, a positive 4 and a negative 6 is a negative 2i. And that's my answer. And that's all there is to adding and subtracting complex numbers. Questions on that? Okay, moving on. All right, this PowerPoint had this yellow thing right here and I was like, huh? So I added this gray thing up here. I put it in there because when I see my product, you know, I see, whoops, didn't mean to do that. I see parentheses next to parentheses, you know, and that's code for, hey, multiply us, but they're also binomials. So my gut instinct is, hey, just FOIL method that. And so I'd be like, okay, take the first times the first, A times C is whatever A times C is. Then I would do my last term times my last term, and A times DI would be an ADI. And then O is outside, so that was outside, sorry. Inside would be this guy and that guy. So BI times C would be a CBI or a BCI. I guess I should have put those in alphabetical order. It doesn't matter. There's going to be numbers there. You just multiply them. And then last times last, I would take the BI times the DI. And that's going to be a BDI squared. But I squared is really the I squared here, that's really a -1. So whatever B times D is, you're going to multiply that times a -1. And so that ends up being a negative BD. And these two are like terms. Remember, whatever A times D is, that's going to be a number and that's going to be a number. And you're just going to add those numbers together. And then the A is just, or sorry, the I is just hanging out right there. So that's the way I'm going to do it. But apparently there's this other method where they just tell you to take A times C, that's right there, and then take the B times the D, which is right there, but then you have to remember to subtract it. See, when I run into that I squared, that reminds me that there's a -1 there, which causes the subtraction right here. But with their method, you have to remember to subtract. So I'm not a fan of their method here. And then they went on to say, take A times D, yeah, I'm not liking this, and then B times C, and then you got to remember to stick the I in there. So yeah, I just use the old FOIL method because it works. it's going to work. So if it's okay with you, that's what I'm going to do. And I just made a rhyme. All right, so and then they do this other example where they use the distributive property. I see 5 plus 3i times 2 plus 2i, and they said, hey, let's just take the 5 and distribute it. So this is a totally other method, and that's what they're showing here. Take 5 times 2 and 5 times 7i. 5 times 2 is 10. 5 times 7i is 35i. Then they go back and they get the 3i and they're like, let's distribute that through the second set of parentheses, which is what they're showing right here. 3i times 2 is 6i. And then 3i times 7i is 21i squared. But the I squared is a -1. And then it looks like they went ahead and combined these two. 35i and 6i is 41i altogether. And then, of course, 21 times -1 is -21. Combined with the 10, 10 minus 21, that's where they got the -11. Plus the 41i, it's still there. You can't combine those two. And the other thing you have to make sure is my math lab always wants the answer in A plus BI form, or possibly A minus BI form, or there could be a minus sign here. You know, the signs don't matter. They want the real part first, the imaginary part second. So don't be trying to write 41i minus 11. It'll probably count it wrong because my math lab can be very picky based on their directions. Okay. What's next? Okay, now, when you get to the division part, before you can do division, you have to learn about something called a conjugate. And in this textbook, they are putting a horizontal line above the letters, which means they want the conjugate. So if Z is equal to A plus BI, then its conjugate, which would be Z with a line on top of it, it's literally just going to be, instead of A plus BI, it'll be A minus BI. Now, you've seen the conjugates before. We did that the other day when we were, I was going over the FOIL method, and you had like an x plus 3 times an x minus 3. I called those binomial conjugates. It's the same word. This is just a different format, but you need the conjugate in order to divide. So that's all the conjugate is. It's the exact same complex number, except you use the opposite sign. So if I'm given an A minus BI, my conjugate would be A plus BI. So just do the opposite. Okay, so here they actually practice just multiplying the complex conjugates because something funky happens when you FOIL them out. So let's see, it says find the product of the complex number Z, which is 3 plus 4i, and its conjugate, Z with a line on top of it. Well, if this is your complex number, 3 plus 4i, then the conjugate would be this one, 3 minus 4i. And now I'm just going to FOIL it, and that's what they did here. If you take first times first, right, 3 times 3, that gives you 9. Then if I go to my outsides, that would be this 3 times a -4i. 3 times -4i is -12i. Then if I go to my insides, this is 4i times 3, and that's +12i. And then I need one more color. How about dark green? When I go last times last, I'm taking a negative, or a positive 4i times a negative 4i, and that's going to be a negative 16i squared. Now, just like when we were doing the binomial conjugates, outsides and insides cancel out. They're gone, which means the imaginary I goes away right there. And then back here on this 16i squared, remember this is minus 16 times I squared is really a negative 1. And negative times a negative makes that a positive 16. And that no longer has the imaginary number I in it either. So when you take a complex number times its conjugate, it becomes a real number. And I used to do this really lame Pinocchio joke about, I'm a real boy. You know, it's not real. It's not imaginary anymore because Pinocchio is an imaginary little puppet boy. Y'all remember Pinocchio? Or am I too old? Okay, nobody's laughing. All right. So that's the whole deal. When you multiply it times its conjugate, boom, it becomes real. And so they come up with this theorem, but it's the same goofy theorem that I had the other day where I told you when you multiply a binomial times its conjugate, you don't have to FOIL, you just have to FOL, you know. The FOIL method is first, outside, inside, last, but outsides and insides always cancel. So you just, you know, FL it, full. And that's what they're trying to say here. Just take the a squared times the b squared and add them together. That's all you have to do. A squared is first times first. B squared is last times last. However, when we were doing that x plus 3 times x, boy, that doesn't write very well, x minus 3, first times first is x squared, and last times last is a minus 9, which gives you a difference of 2 squares. But those aren't complex numbers. Those are just regular old polynomials. What was that? I heard a weird noise. Don't know what it was. I'm plugged in. So really all you have to do is a times a, and then when you take a plus bi times another plus bi, the I squared becomes a negative 1, but the plus times the minus is another minus, and so it ends up being a minus and a minus, which is a plus again. Oh my God. So it's just a squared plus b squared. The good news is that if this is all confusing to you, it doesn't matter because you can just FOIL it and it's going to work out because the FOIL method works all the time. So just FOIL it. Okay, so here's the hard part. This is the division, and they're going to present the division to you in fraction form because I really have, when you put this line right here, this is the same thing as saying take a 1 plus 4i and divide it by a 5 minus 12i. But you can't just cross cancel things out because these are also binomials. All right. So what you have to do is something called, and they don't put it in this book, rationalizing the denominator. You have to get the imaginary number out of the denominator, which means you have to make your denominator a real number. And it's called rationalizing it. You're making it into a rational number. It's not irrational and it's not complex. It's going to be a regular old number. And that's where the conjugate comes into play. But we are also in fraction land. And when you're in fraction land, you must abide by fraction laws. And the main law in fraction land is whatever you multiply the denominator by, you have to multiply the numerator by the same thing. And what are we going to multiply it by? The conjugate of the denominator. You're rationalizing the denominator. You want to get the imaginary number out of the denominator. So I have to rationalize it with its conjugate. But if you mess with the bottom, you got to mess with the top the exact same way. So I have to multiply them both. Now, I clearly have to FOIL the numerator. If you remember the a squared plus b squared, that'll save you some time. So it does help to remember it, so you don't have to always FOIL it. But, or you can at least remember that it's first times first and last times last, because they're conjugates, you know, it's that whole full thing. So if I multiply 5 times 5, that's 25. And then if I multiply a minus 12i times a plus 12i, that's a minus 144i squared. But the I squared is really a negative 1. So what I really have is now 25 minus 144 times negative 1, which is 25. I'm going to look at this as a negative 144 times a negative 1 and make it a plus 144. And that adds up to 169. That's just my denominator. So my denominator, oops, meant to make that red, sorry. My denominator is 169. Now I still have to FOIL out my numerator. So first times first, 1 times 5 is 5. My outsides would be plus 12i. My insides will be plus 20i. And last times last is a plus 48i squared. But just like before, that I squared, this is really going to be a minus 48 because your I squared right here is really a negative 1. And a positive 48 times a negative 1 makes it a negative 48, which I would then combine with that 5. 5 minus 48 is a negative 43. And then I also have to combine my i's. 12i and 20i is what? 32i. So plus 32i. Now, here's the really, really, really fun part about my math lab is they're going to ask you to put your answer in a plus bi form. This is a plus bi all over a c. They don't want that. They want you to literally split it up and give each number in the numerator its own denominator. And then the I gets to be popped out on the side like that. And then if either one of these can be reduced, which they can't, you should reduce fractions. At this point in your mathematical career at a college algebra level, you should not have to be told to put your fractional answers in simplest form. You should just automatically do it. But neither one of those can be reduced. So that's my answer. It's ugly, but that's my answer. Questions on that mess?
I have a question.
Yeah.
So your denominator is always just going to be the opposite of what the original is, basically, but you're always going to FOIL the numerator. You don't FOIL the denominator, you just FOIL the numerator.
Yeah, I technically did FOIL the denominator, but because they're conjugates, outsides and insides always cancel. So I didn't bother doing outsides and insides because I knew they were going to cancel.
Okay, I just wanted to make sure because that's how I figured it too. And I'm like, well, maybe she just cut out the middle part. So, okay, perfect.
Yeah, because when you do conjugates, they will always cancel. So that's my lame joke. You don't have to FOIL, you just have to FL, conjugates, skipping the O and the I. But you can write it all out. That's fine because they will cancel. So you will get the same answer I do.
Does my math lab require you to show steps?
No. Just the answer. Okay, now I'm going to erase this one and I'm going to do the next one also because I kind of ran out of room here. Or actually, you know what? I'm not going to erase it because I want to keep it there for when I do it. I'm just going to add a slide in here. Oh, I don't like that slide. A blank slide. Just give me a blank slide. There we go. Blank slide. And then the problem was 2 minus 3i over 4 minus 3i. So I'm getting old. Can't remember things. 2 minus 3i over 4 minus 3i. Okay, cool. All right. So it's the denominator that you have to focus on from the beginning, and you need his conjugate. So the conjugate of 4 minus 3i would be 4 plus 3i. But since I messed with the bottom, I got to mess with the top the exact same way because that's a fraction law. Now, if I went ahead and did the numerator and I FOILed it all the way out, first times first is 2 times 4. That's 8. Then my outsides are 2 times the 3i. That's 6i. My insides would be negative 3i times 4 is negative 12i. And then last times last, it's a negative times a positive, which is a negative. And 3i times 3i is 9i squared. Now, if I went ahead and did the denominator, first times first is 16. I wouldn't bother doing outsides and insides. They just cancel. And then last times last is the same as it was above. That's going to be another minus 9i squared. But the I squareds are actually negative ones. So my denominator is really 16 minus 9 times a negative 1, which means my denominator is really 16 plus 9, also known as 25. And then up in my numerator, my minus 9i squared is really a minus 9 times negative 1. And that also becomes a plus 9. And I would take this plus 9 here and combine it with the 8. That's going to be 17. And then I would add the 6i and the negative 12i. I'm going to combine those two. That would be minus 6i. And it'd be great if my math lab took it like that, but it wants it in a plus bi form. So you just give the 17 his own denominator of 25, and then put minus, then give the 6 his own denominator of 25. And then the I is just kind of popped out on the side. So it looks like A plus BI form. A is 17/25 and B is the minus 6/25, and then I is I. I. And that's that. Okay. Oh, and then this is just their slide where they show how they did it and wrote it all out. So I just left that slide in there, even though I worked it out. Okay, now, the only other thing I can teach you about the powers of I is when you have an I raised to something bigger than a squared, like an I cubed or an I to the 4th or an I to the 5th or an I to the 6th or so on and so forth. There's actually a pattern here. If you have I to the 1st, that's just I. And then I squared is -1. So let's see. I to the first is I squared is -1. But then when you get to I cubed is actually an I squared times an I. If you remember your exponent rules, 2 + 1 is 3. And the I squared is a -1 times the I. So what you get for I cubed is -1. Okay. So when you have I to the first, that is just I. When you have I to the second, that is -1. When you have I to the third, that is -I, which then brings me to I to the fourth. And what they did is they said, well, I to the fourth is an I squared times an I squared, which is a -1 times a -1, which is a +1. So I to the fourth is +1. Now over here on the other side of the page, it goes from I to the fourth to I to the fifth. But I to the fifth, oh my gosh, another color. Come on. I to the fifth is an I to the fourth times I, and I to the fourth is a 1, and 1 times I is I. You're back to I again. And then the next one is -1, which is the same thing as I squared. And then I to the seventh is -I, which is the same as I to the third. And then I to the eighth is 1, which is the same as I to the fourth. This is the pattern that keeps repeating. Every 4 it repeats. 1, 2, 3, 4 goes I, -1, -I, 1. 5, 6, 7, 8 is I, -1, -I, 1. 9, 10, 11, 12 would be I, -1, -I, 1. That's the pattern. And hopefully you can remember it. If not, it's not hard to sit down and calculate this. And then you just have to remember it repeats every 4. So you're going to deal with that with problems like these. So what they did is they took I to the 27th, and they basically used that basic exponent rule that says if you have x to the a times x to the b, it's x to the a plus b. And they broke it into 2 numbers that add up to 27, but one of those numbers is divisible by 4. So 27 is not divisible by 4. So you're like, well, do I do 26 and 1? No, because neither of those is divisible by 4. So do I do 25 and 2? That adds up to 27. No, because neither of those are divisible by 4. So then you're like, okay, how about 24 and 3? That adds up to 27. Bing, bing, bing. Yeah, because 24 is divisible by 4 6 times. And then you have to remember that I to the fourth is 1. So instead of I to the fourth to the 6th power, you've got 1 to the 6th power, which is really just 1. Which means you're left with, the I to the third. And then you have to remember, okay, I to the third is a -I. Now, that's one way to do it. The way I like to do it is this. Different color here. Red's my favorite color, by the way. What I do is I take the 27 and I divide it by 4. It goes in there 6 whole times. See, there's the 24. And when you subtract, whatever you're left over with, I'm left with 3 left over. I to the 27th is the same thing as I to the 3 left over, which you can see it's right here, because this mess here just ends up being a 1. And 1 times I cubed is I cubed. It always works that way. So like on part B, they've got I to the 101. They broke it down to be I to the 100 because 4 goes into 100 25 times. So they've got I to the 4th raised to the 25th. But I to the 4th is a 1, and 1 to the 25th is a 1. And 1 times I is just I, because you're left with this I to the 1st. But if I did my method on it, let me switch to a different color. And I said, okay, take 101, divide it by 4. Goes in there 25 times, that's 100, with 1 left over. It's always a leftover. So I'm like, I to the 101 is going to simplify to be I to the 1st, the 1 left over. And I to the 1st is just I. I like my method better, but either one works. Whatever the leftover part is, that's what it's always going to simplify down to be. Period. Okay, and then, oh, I actually already did this with you early on. If n, this slide should be back at the beginning. If n is a positive real number, we define the principal square root of negative n, denoted by the square root of negative n, as the square root of negative n equals the square root of n times I. This is like when I was doing the square root of negative 4. I broke it up and said the square root of 4 times the square root of negative 1, which is really the square root of 4 times I. That's what they're trying to show here. Of course, we can take the square root of 4, that is 2. Sometimes in my math lab, though, you might get an answer that's like the square root of 5. I wouldn't write it the square root of 5 times I. I would write it as I times the square root of 5. Because the 5 is still what I say is trapped in radical land, and I is not. And it is too easy, like right here, if I erase this, especially when you're writing it on paper, it is too easy to make this line go a little bit too far. And then I'm like, is that the square root of 5i or the square root of 5 times an I? If you stick this I out in front, there is no doubting what the answer is. It's I times the square root of 5. So put the I in front of the radical. So you might have an answer that's like 7 minus 2i times the square root of 3. It's ugly, but it's an answer. All right. Now I'm getting ready to do examples that I pulled straight out of Math Lab. So does anybody have any questions before? I've pretty much done the lecture part of all the concepts we're covering here. And now I'm just going to go through as many of my Math Labs as I've got time for in the next 25 minutes or so. Any questions about math? I'm sure you have lots of questions. Can't answer them all. All right, so let's do this. I really like using the highlighters, but now I realize that they block, you know, because it's easier to go take this this 1 right here and this 6 right there and add them together, and that's going to be the answer for your real part, which would be, and then I can just use black all the time. That would be what, 7? And then I'm going to combine, come on, my negative 4i plus my 2i, and that's going to be my imaginary part right here, which negative 4 and positive 2 is a negative 2i. And that's my answer, 7 minus 2i. Remember, adding and subtracting, piece of cake. Add the real crap to the real crap, the imaginary crap to the imaginary crap, and make sure your answer is in the form of a plus bi. My math lab wants that. And then this one is a subtraction problem. Now you can either do the subtraction or you can distribute and then just combine like terms. That's up to you. I'll do it both ways. Let me use a pen. If I had negative 9 minus a positive 9, in my head I'm seeing this, negative 9 minus 9. Here's me having a thought. Here I am right here. Got my long hair. Smiley face. Okay. Negative 9 minus 9 is negative 18. And then I would say positive 6i minus the negative 5i. So I'm seeing it like this, 6i minus negative 5i. But subtracting a negative is the same as adding a positive. And 6 and 5 is 11i. And that's a positive, so I'd put plus 11i. And that's my answer. And of course, the other way is if you wanted to, you could distribute to get rid of your parentheses. So I'd have negative 9 plus 6i. But when I distribute this minus sign here, sorry, I thought I switched. There we go. If I distribute the minus sign to this, that's going to be minus 9 plus 5i. And then it's just a case of combining like terms. I've got minus 9 and another minus 9. Those come together as a minus 18. And then I've got 6 plus 6i and plus 5i. And that becomes a plus 11i. Same answer. Either way works. Whatever floats your boat. Okay, so that was adding and subtracting. Now they move us into multiplication. Now this one actually just has a 3i. It's just imaginary. The complex or the real part's missing from that complex number. So you're literally just going to distribute on problems like this. So I'm going to take this 3i right here, and I'm going to distribute it and multiply it times the 5i. 3 times 5 is 15, but the I just goes along for the ride. Then you're going to go back and get the 3i again, and this time distribute it to the minus I. It's a positive times a negative, which makes it a negative. And 3i times I is 3i squared. But then you have to realize that the I squared is really a negative 1. Okay, come with me, I've run out of room. So now I've got 15i, and then this minus 3 times minus 1, that becomes a plus 3. And my math lab right here says type your answer in the form of a plus bi. They won't like it as 15i plus 3. You got to reverse it and write 3 plus 15i. You know, I'm sorry, my math lab can be picky, but you know what? Sometimes your boss can be picky too, and there's not a damn thing you can do about it. So deal with it. Okay. Number 4. At first glance, I was like, ooh, conjugates. But then I was like, oh man, no, they're not. I got an 8 minus 5i, and then an 8 plus I. Doesn't have a 5 on it. So we're going to FOIL this guy. I'm going to start with first times first. 8 times 8 is 64. And then I'm going to go with my outsides, which is 8 times I. That's an 8i. Then I'm going to go with my insides. That's a minus 5i times 8, which is a minus 40i. And then last times last, minus 5i times a plus I is a minus 5i squared. Now, after you've done these a gazillion times and you're like, wait a minute, minus 5i squared, that's really going to be a minus 5 times a minus 1. So really, I'm just going to have a plus 5 there for that last term. And now I'm going to combine like terms. So I'm going to take the 64 and the 5. Those are going to combine my real to my real, because becomes my real part of my complex answer, 69. And then I'm going to take my plus 8i and my minus 40i. Those are my imaginary numbers. So that's going to be the bi part, and that's going to be a negative 32i. And that's what I'll type into my math lab. Are we having fun yet? God, I miss the classroom. I feel like I'm just sitting here talking to myself. I guess you guys are listening. Okay. Okay. Now this is technically division, but it's not really division, you know, like normal long division. It is a division problem. It is 5 divided by 9 minus 3i. But the way you simplify it is rationalize the denominator by multiplying it times its conjugate. So I am going to multiply the denominator, which is 9 minus 3i, by a 9 plus 3i. But I'm in fraction land, so whatever I do to the bottom, I have to do to the top. Now, for the top, I'm just going to distribute. I'm going to take the 5 and distribute it. So that's going to be 5 times 9 is 45, and 5 times 3 is 15i. And then on the bottom, since they're conjugates, I'm just going to do first times first and last times last. So, because outsides and insides always cancel. So don't waste your time. First times first, that is 9 times 9 is 81. And then a minus 3i times a plus 3i would be a minus 9i squared, but that's really minus 9 times minus 1, which makes that a plus 9. So there's really a plus 9 right here. And then I can, I don't know why I wrote so big. I can combine my numerator up here, or I'm sorry, I can combine my terms in my denominator. So I got 45 plus 15i, I have to leave it like that, but 81 and 9 is 90. And then you have to put it in the form of a plus bi, because it says it right there. So give the 45 his own 90, plus give the 15 her own 90, and then pop the I right here. But both of these fractions are reducible. 45 actually goes into 90 twice. So 45 over 90 reduces down to 1/2. And then 15 over 90, those are both divisible by 15. And that reduces down to 1/6. And then don't forget the I. So it's 1/2 plus 1/6 of an I. The ayes have it. Okay, next. Oh, this one is just dividing by a single I. In order to rationalize an I, all you have to do is multiply it times another I. Because I times I is I squared, which is -1. But the numerator must also get multiplied by an I. So my denominator, I times I is I squared, but that just becomes a -1. My numerator, I'm going to have to distribute the I. So I get 23i plus I squared, which becomes 23i. And remember, your I squared is a -1, so I'm going to make it -1. But that's all divided by -1. So I'm going to, you're literally going to split it up and give each piece its own -1. So I'm going to give the 23i its own -1 and the -1 its own -1. So I get -23i And then a minus makes this a +1. And then my last step is putting it in the right order, the a plus bi form. Whew, that was fun. It looked more complicated than it really was. I was trying to write out every step for you so that you could see what I was doing. I hope you can see what I'm doing. Looks like I got about 1, 2, 3, 4, 5, 6, 7. I got 8 more to go. I got 14 minutes. I can make it. All right, this one is another one where you're going to rationalize the denominator by multiplying times its conjugate. So 9 minus I over 7 plus I, and its conjugate would be a 7 minus I. But you got to do the same thing to the top. Again, this is called rationalizing the denominator. Putting it in a plus bi form where it's not a fraction. And you can only have one I. So for the numerator, I'm going to FOIL that. 9 times 7 is 63. My outsides is negative 9i. My insides is negative 7i. That's negative 16i altogether. And then last times last, it's a negative times a negative, which makes it a positive. And I times I is I squared. On the denominator, I'm just going to take first times first and last times last, because outsides and insides on conjugates always cancels. So 7 times 7 is 49. And then a positive I times a negative I is a negative I squared. And then you have to remember that this I squared is really a -1, and so is this one. So what I really end up with is in my numerator, another color, green. Actually, I'll just use a highlighter. If I take the 63 and combine it with the -1, that's going to give me 62. And then you'll still have the minus 16i squared, or 16i. And then in the denominator, I would take the 49 minus the -1. Subtracting a negative is adding a positive. So 49 plus 1 makes my denominator of 50. And then I have to rewrite it as, come up here, 62 over 50 minus 16 over 50 I. And then that is going to reduce, let's see, 62 and 50 are both divisible by 2. So 31 over 25. And I can divide the next one by 2. That'd be 8 over 25i. So ugly answer, but it's an a plus bi form. Okay, so that's adding, subtracting, multiplying, and dividing examples. And then number 10 is one of those, just an I raised to a higher power. And I kind of like my method better. So I'm going to take 4 because the pattern repeats every 4. So 4 goes into 11 twice. That is 8 with 3 left over. So that means that my I to the 11th is going to be the same thing as I to the 3 left over. This guy right here. That's what's going to go here. And then I just have to remember that I to the 3rd is a negative I. And I can even write it out for you. I to the 11th, if I split it up, that would be I to the 4th times another I to the 4th times an I to the 3rd. 4 plus 4 is 8 plus 3 is 11. But this I to the 4th is 1, and this I to the 4th is 1, and 1 times I cubed is just I cubed. Those 4's just go away. Those I to the 4ths are 1s. They just kind of go away. Okay, so that's that. And then, okay, this one's just evil. because they threw in a negative exponent. So what I did is I remembered that negative exponent rule that says if you have x raised to the negative a power, that's the same thing as 1 over x to the positive a. So I used that rule first and I said, okay, this is going to be 1 over I to the positive 76th. And then I did my trick to figure out, is I to the 76th I squared, I cubed, or I to the 4th? So I took my 4, divided it into 76. Actually, I don't have much room there. Let me do it over here. I took 4 into 76. That goes once. Doing long division here, taking you back to like, what, 3rd, 4th grade when you started this? 4 goes into 36, exactly 9 times. Ooh, with 0 left over. I to the 76th is actually I to the 0. And hopefully everyone remembers that anything raised to the 0 power is 1. And 1 over 1 is 1. So that's my answer. It's just 1. Uno. Oh, what fresh hell is this? Okay. If your first instinct is, oh, just combine like terms. No, you can't add I cubes to I to the 5ths. You can only add I cubes to other I cubes. So I'm gonna have to simplify this. And I cubed, let's see, I've got 9 I cubed minus 7 I to the 4th. I cubed is the same thing as a negative I. And then I to the 5th, 4 goes into 5 one time with 1 left over. So I to the 5th is the same thing as I to the 1 left over. So what I have here is 9 times negative I minus 7 times I to the 1st. So this is negative 9I minus 7I. And now I got like terms. That's negative 16I. How we doing? Any questions on anything? Hope you're still there. Okay, and this is just one where it wants you to simplify it. Before in the indicated operation, express your answer in the form of a plus bi. The square root of negative 16, that's the square root of 16 times the square root of a negative 1. The square root of 16 is 4. The square root of negative 1 is an I, and 4 times I is just a 4I. I didn't have a chance to check my math lab. Let me do that now. Let me see if I can get in there. Nope, where's my math lab? Here it is. This was question 15. Can you guys see my math lab? Oh, it logged me out. Enter me back in. Okay, I just wanted to see if it'll accept. This one would be 3i. 3i and hit enter. Yep, it took it. I just wondered if it wanted the 0. So let me go back. And if I hit similar question, I'm just curious. Oh, here's mine, square root of negative 16. What if I put 0 plus 4i? Is it going to yell at me for that? Nope, it took that too. Because when it says a plus bi, I figured they wanted a number where the a was, which would be 0. Because there was no visible number. I just had 4i as my answer. But it took it either way, so all is good in the world. All right, back to this. 3 more. Okay, the last 3 are, yep, just solving back to quadratic equations. So this one has the, it has the x squared term, So that makes it quadratic, which means I'll have two answers for x. And then all it has is the constant. It doesn't have the middle term, you know, like a 7x or something. So I could use the quadratic formula if I wanted, but I'm going to solve this by taking square roots, because that method only works when the only variable is the squared variable. So step one, I'm going to subtract the 49 over to the other side. Boom, it cancels out there. I'll have x squared is equal to negative 49. And now I'm going to square root both sides. I'm going to take the square root of x squared and the square root of a negative 49. The square root of x squared is just x. And remember, there's got to be two answers. So it's either the positive or the negative of whatever the square root of negative 49 is. And that would be 7i. Let's see. Solution set is blank. Simplify your answer. Use a comma to separate answers as needed. So I'd be putting 7i, comma, negative 7i, or the reverse order. It doesn't matter. But remember, quadratics, because they have this x squared, you have to have two answers. Oh, I got 3 minutes. Solve this one. It's a quadratic, x squared. It cannot be factored because there's no two factors of 6 that add up to 3. So I'm going to have to use the quadratic formula. And when you're looking at it, remember it's in the ax squared plus bx plus c equals 0 form. A is this invisible 1 right here. B is the 3. And c is the 6. And the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So I'm going to take out all the letters, and I always put parentheses in their place. Makes it easy when I go to plug in the numbers, and I like to use a different color. So a was 1, my a was here and here, right? A was 1. B was 3, so I need a 3 here and a 3 there. And C was 6. So there's that. Okay, so x is going to equal negative 3 plus or minus the square root of, let's see, 3 squared is 9, and then I've got minus 4 times 1 times 6, so that's a minus 24 all over 2 times 1 is 2. So that's negative 3 plus or minus the square root of negative 15 all over 2. And now all I have to do is get the I out of there. So this is going to be negative 3 plus or minus I square roots of 15 all over 2. Remember, the square root of the negative, that comes out as an I. Put it in front of the radical. 15 is not a perfect square, and it doesn't have any perfect square factors, so I can't simplify it. This is my answer, and what's going to be fun is typing it into my math lab. You'll have to type in, oh crap, oh, they even said answer in the form of a plus bi. That is so not nice. Okay, let me add a slide. Slide. So the way you're going to have to write these answers is, oh God, it was negative 3 plus or minus I square roots of 15 all over 2. Okay. First, you're going to give the negative 3 its own denominator of 2. Then you're going to put the plus or minus sign. You're going to give the square root of 15 its own denominator of 2. And then this I has to get popped out like that on the side. And as two separate answers, it's -3/2 plus the square root of 15/2 times I, comma, -3/2 minus the square root of 15/2 I. Ew, that's going to be a pain in the butt. And then the very last slide, sorry, I'm going over a couple of minutes. It just asks about the answer. Is it going to be two complex conjugate solutions, one repeated real number solution, or two unequal real number solutions? And that involves the square root thingy. Oh, my brain, I'm having a brain fart. What is that thing called? But first things first, you have to set it equal to 0 first. So I have to subtract 2 on both sides. That gives me 2x squared plus 4x minus 2 equals 0. And then A is equal to 2, B is equal to 4, and C is equal to a -2. The discriminant, I just remembered, the discriminant. The discriminant is the B squared minus 4AC part. That determines whether you have 2 real, 2 imaginary, or 1 real answer. So it's going to be the square root of B squared minus 4 times A times C. And B was a 4, and A was a 2, and C was a -2. So this is going to be the square root of 16 minus 4 times 2 times minus 2 is a plus 16. That gives me the square root of 32. If you have a square root of negative, that's going to be the complex answer. I don't have the square root of a negative, that's out. And if this were a perfect square, that would be one answer, but I don't have a perfect square. I have the square root of 32. So I am definitely going to have a plus or minus 32 on here. So it's two unequal real number solutions. Actually, I take that back. Not a perfect square. This would have to be a 0. If it's a 0, that's when you'd get this. And now I'm done. So I'm going to stop sharing my screen. Oh, you're all still there. Are you awake? I'm done. Anybody got any questions?
No questions for me.
Jared, you got a question? Or is that just a hand?
I'm good. I thought it said clap.
Oh, okay. I see it. Clap. Were you applauding my, I got another clap. Got another clap. Oh, thank you. All right. Well, I'm going to save the PowerPoint and upload it under modules, and it takes a few minutes for the video to process, and then I'm just going to upload it into my YouTube page. Okay. And your section 1.3 homework is ready to go to be worked on. If you haven't watched the video that shows you how to navigate through my math lab, it's about 10 minutes, but watch it because it explains all the help me buttons. It explains how you can send me an email. It explains how you can actually print out the homework so you don't have to stare at the computer screen the whole time. You can work it on paper and then go back in and just put in answers. It shows you how you can jump around. I go through it all. So if there's nothing else, I'm going to end the meeting and say bye-bye. See you Wednesday.
Bye.
Bye. See ya.
Adios.
Ciao. Hasta la vista. Christian, do you have a question? Or Kayla, you got a question? Nope. Kayla, you got a question? All right, I'm going to end the meeting then. Bye, Kayla.